I'm Miranda Cosgrove, and this is Mission Unstoppable. Coming up, food is fuel, literally.
People are typically surprised that you can make fuel out of something like a soybean.
See how science can help a soybean power the world. Then, you can call her Miss Maps. Even now, in her 90s, Gladys is proud of her work developing GPS. I spill the STEM tea on the mother of GPS. And meet the scientist who's building bone out of oysters?
The one that works the best are the pearl oysters.
Does that mean we can get pearl skeletons? Plus, this woman is taking the fear of math out of the equation. Get ready to meet the scientists, inventors, and heroes who help make our world a better place. The future is here. The mission, unstoppable. Soy fuel in Spanish means I am fuel. But in English, soy fuel is what our next segment's about. Check it out. When you see a soybean, it's easy to think of it as a food for humans, or even feed for livestock. But did you know the oil from soy can also feed trucks? Okay, this vehicle may not eat edamame, but with a dash of chemistry, this renewable resource can be used to power big rigs, trains, and even planes. All it needs is a little makeover from a chemical engineer, like Bauguess.
People are typically surprised that you can make fuel out of something like a soybean. The bread and butter of chemical engineering is that you really are just playing with different chemicals, kind of like building blocks. And that is what drew me to this plant life, as it's called.
Katie began her career at a conventional oil plant, but a desire to end climate change led to her work with sustainable fuels here at World Energy, a partner of show sponsor United Soybean Board.
Conventional fuel is essentially just a chain of carbon. We are trying to create that same carbon chain using renewable things like soybean or waste fats, oils, and greases.
On an atomic scale, soybean oil and fats like it are also chains of carbon, known as triglycerides.
The triglyceride is 3 carbon chains against a propane backbone.
These molecules can be rearranged to create fuels similar in properties to petroleum-based products without the same high levels of emissions. But you don't have to take my word for it. See for yourself.
So right here we have conventional petroleum diesel. You can see it's kind of yellow. That's more particulate matter that's in it. Here we have our renewable diesel.
When the fuels are put to use, the contrast is even clearer.
The conventional diesel has a lot more soot, a lot more smoke that's coming out of it, and the renewable diesel is burning a lot cleaner.
When a fuel burns cleaner, you're just putting less emissions out into the air. It's just cleaner air, to put it simply.
Today, Katie's going to show us how this refinery creates a cleaner burning fuel in just a few steps.
So this is where we make the renewable fuels.
First, triglycerides are heated up to over 500 degrees Fahrenheit and pumped into a reactor where they're cleaned using H2 gas.
These big, tall vessels behind me are hydrotreating reactors.
The hydrogen breaks up this triglyceride, gets rid of things like oxygen, any other impurities we might see in there.
Next, the mixture undergoes 2 crucial chemical reactions, known as cracking and isomerizing.
Very similar to the first reactors, we've used hydrogen and then it cracks, which is chopping off the long carbon chains, or it's isomerizing, which is basically moving around the carbon to make the fuel properties just a little bit different.
By rearranging the carbon molecules, a variety of fuels are created, from longer carbon chains of diesel to shorter strands of jet fuel. Splitting these fuels apart is step 3.
So behind me you can see we have our main fractionator, and what that's doing is it's separating out the different type of fuels. It's using pressure and temperature to help boil off different types of fuel.
The fuels are pumped into their assigned storage tanks. This one alone can hold close to 1 million gallons. Then it's time for the final step, quality control.
One of the important parts is making sure our product's on spec. So let's go take a look at the sample.
That means visually checking for impurities or discoloration, then testing fuels for their cold flow properties, like freeze point.
How does that look? Pretty good.
Since 2011, use of renewable fuels by drivers in California alone have decreased carbon emissions by 81.1 billion pounds. That's like taking every registered car in Illinois and Ohio combined off the road for an entire year.
I'm really proud I work in a process that actually is moving the needle and working towards fighting climate change on a day-to-day basis.
Now you know, that's how a little soybean and a lot of science can help drive us towards a cleaner future. There better be some tofu there. For some reason, I'm kind of hungry. Our ancestors explored the world with star charts, primitive maps, even songs that passed down important navigational knowledge across generations, which all sounds very impressive, but it's way easier to just tell your phone where you want to go. We have that power thanks to the woman who gave the world GPS, and today it's guiding us to the STEM T. From the satellite navigation we use driving to the locations we tag on social media, most of us use global positioning systems every day. One woman of the STEM sisterhood was instrumental to the development of GPS, and her story was mostly untold until a few years ago. Born in 1930 in Sutherland, Virginia, Gladys West knew at a young age she wanted to escape her small rural town. She absolutely hated standing in the heat of the day, tending to crops and dealing with bugs. Gladys felt her ticket out of farm life was education, so she pursued a career in mathematics. Growing up without a lot of money, she had to keep up her grades to earn her opportunities. When a state scholarship became available to the top 2 students in her class, Gladys worked extra hard and snagged one of them, becoming valedictorian, which allowed her to attend Virginia State College. She didn't know it at the time, but her passion for her own education created a ripple effect that created new opportunities for Black women everywhere. Undergraduate studies turned to teaching, and eventually she received a master's in mathematics that landed her a job at the Naval Base in Dahlgren, Virginia. Gladys was the second Black woman to work as a programmer at the base and one of only 4 Black employees. At the start of her job in 1956, the Navy was just beginning to bring in computers for the first time, and Gladys was hired to run them. She worked tirelessly, teaching herself programming and code along the way. And this was decades before you could just look up code online. Her time working at the Naval Base overlapped with the newly unfolding civil rights battle across the country. Gladys felt conflicted. Her government job didn't allow her to join the peaceful protests, so she decided to participate in another way. She continued her work inside the base in hopes that she could chip away at the stigma many Black women faced in the workforce. In the early 60s, she took part in an award-winning study that proved the regularity of Pluto's motion relative to Neptune. Basically, for every 2 orbits Pluto makes around the sun, Neptune makes 3. Later, she became the project manager for a satellite monitoring Earth's oceans. In this project, she led a team of 5 people, programming calculations for an accurate geodetic Earth model on one of the fastest computers of the time, the IBM 7030 Stretch computer. Back then, computers had nicknames. They should bring that back. You could call your laptop Ramantha, Operating Sister, Gigalicious, MacBrook. West would collect and process data from satellites to identify their exact location. The calculations from this model laid the groundwork for what would become the Global Positioning System Orbit, GPS. See, it stands for something. Like many of the hidden figures in America's aeronautics and space history, it took time for Dr. West to get recognition for her work developing GPS. West claims that she didn't even realize her efforts were revolutionizing technology across the world, and she never thought her time in the military to be especially exciting. She was even more surprised to see her work become an essential part of civilian life. For Gladys, it was just honest, challenging work, and later in life, she was amazed to see others so excited by what she'd accomplished. In 2018, West was officially recognized for her decades of world-changing innovations when she was inducted into the Air Force Hall of Fame. Even now, in her 90s, Gladys is proud of her work developing GPS, but she still doesn't use it herself. She prefers the hands-on experience of paper maps. I've always been a GPS girly, but let's try to see how this thing works. I'm heading to Rancho Cucamonga, so wish me luck. What are oysters hiding in their little shells? Pearls, probably, but also science. Our next guest is combining modern technology with ancient knowledge to create the future of medicine.
About 4,000 years ago, the Maya people invented a calendar, built stunning pyramids, and discovered that human teeth can be regrown with oyster shells. What? Oyster shells? But how? Unraveling this mystery is Ronke Olabisi. Ronke is a biomedical engineer at Rutgers University, and she's going to tell me how modern science is studying this ancient discovery to not only fix teeth, but even build bones. And we're doing it over lunch because oysters factor into the equation.
So is it true that you may have figured out a way to make oyster shells replace human bones?
Actually, I didn't figure it out. The Mayans figured it out.
Okay, shout out to the Mayans.
Right? They're super cool. So there was this fragment of this Mayan jaw that was found in the 1930s. And in that jaw were 3 teeth that were made completely of nacre.
Nacre.
Nacre is the beautiful shiny part on the inside of seashells. So it's also called mother of pearl. This jaw fragment sat in a museum until 1972 when this dentist, Dr. Bobbio, asked if he could x-ray it. And after he x-rayed it, he saw that the bone had integrated into the nacre. So it was the first endoceous bone implant ever.
Endoceous meaning like?
Meaning into the bone, like grown into the bone. And so the Maya had better tooth implants than we do today.
Incredible. Sounds like I would have actually enjoyed going to the dentist.
Now, the one that works the best are the pearl oysters. These are pearl oysters. All of these are mollusks, which is just a type of sea creature, really. These don't form bone in the same way that these do.
The nacre in Pinctada maxima is one of the strongest and most resilient materials in nature.
So I could, if I wanted to, probably break this with my hands. This destroyed a drill bit.
I want that in my body. I want the strong one. Knowing that they can destroy drill bits, do you ever just want to repurpose that word to mean cool stuff? Like, do you ever just, you're just like, that's so Pinctada maxima?
Oh, I should. I did wear mother of pearl earrings when I got married.
All this talk of oysters is making me hungry.
Whew.
But I think I'll stick to learning about them instead of eating them.
That was not very Pinctada maxima, the way my stomach took that down.
Now, we're all suited up in lab coats to take a look at how nacre helps build bone in a process called microencapsulation. Tiny particles are surrounded by a bubble-like coating to protect them, but they can only be seen under a microscope.
So in here is my nacre, and I just drop a little bit of that into my oil. Now we put our sunglasses, because this light is intense. Okay, so drop it in the hole.
This awesome machine has an even awesomer name, a vortex. It's like a tiny blender for science. It creates an emulsion, which is a mixture of 2 or more liquids that usually are unmixable. Next, we take this to the microscope to check out our tiny encapsulated nacre cells.
So all of these little spheres are the microspheres, and these little clumps inside of them are the cells. The reason that we're doing this is because if I want to make something complex like a hip, I need to be able to do it simply first. If I can't make a ball of bone, I can't make a hip. So first we look at these over a period of 2 to 3 weeks and see if they make bone. And if they make bone, then hopefully one day we can grow you a new femur or a new foot or something like that.
Hopefully I won't ever need a new foot, but if I do, I know who to call. Thanks to Ronke Olabisi for having me and for making me feel Pinctada maxima.
Our cameras may cut, but the science never stops rolling. Let's check my messages to see what Ronke has been up to recently.
Hi, Miranda. Since we last filmed, a really cool thing happened. A student from a community college reached out to me after seeing the show. She wanted to know if there was any way she could do a research opportunity. So I was able to set up a remote research opportunity for her, and she used that to leverage herself from a community college into a 4-year university where she is pursuing her dream. This student was inspired by your show, and she's like inspiring to me. I just want to thank you for inspiring the next generation. Please keep doing it. And right now I have to get back to the lab. So bye.
us are afraid of math, which makes sense. There are so many numbers you could never fight them all. But luckily, there are people like Arlene Resendiz who note that math doesn't have to be so scary. If your nightmares are made of math problems, you're far from alone. Studies show that approximately 93% of American adults suffer from math anxiety. But one social media tutor is on a mission to make math accessible to everyone. Meet Arlene Resendiz, AKA Silent Math.
So what inspired me to be a math tutor was just always seeing my family and my friends struggle in it. I always loved math. I see it with such clarity, and my goal is to help others see it that way so that they can love it as well.
Arlene's penchant for tutoring started in high school, helping her peers with homework. After college, she took a job at a local math center, tutoring students of all ages.
I noticed that a lot of people, even kids, feel defeated when learning math because they may feel this pressure to be perfect when they start learning it in school. But in reality, everyone learns at a different pace. So I decided to become a social media influencer for math. And this way my teaching can help students from all over the world. And that makes me so happy because I know that my way of teaching is very special and unique, and it will help a lot of people love it as much as I do.
Hello, welcome back to my channel. My name is Arlene, and I am the tutor for Silent Math.
The trick to multiplying by 99 is to multiply the other number by 100 first, then subtracting it from itself, leaving you with 1782.
Within a year, Arlene amassed thousands of followers who watch from all over the world as she breaks down traditional methods of problem solving into a myriad of math hacks.
Math hacks are super helpful because there is not just one way to solve math. There are multiple ways. You just have to figure out that one way that works for you.
From subtracting whole numbers,
A lot of you guys know that tricks work with only certain numbers.
to complex multiplication,
And that is our final answer.
to mastering exponents,
Cool, right? One of the most rewarding things about being a math tutor is helping my students build their confidence. Because if they don't have the confidence, then it's really hard for them to learn something new, especially if they don't have a good relationship with math.
That's all there is to it. I hope you enjoyed that lesson.
Arlene hopes her math tutorials help people discover their own way into a love of numbers.
I hope that by posting my math videos on social media and even helping my students in person, that I can change the world. Not many people pursue careers in STEM just because of their fear of math. So I hope that I can inspire them to go outside their box, believe in themselves, and learn from my videos.
Stick around. We've got one last thing after the break. Welcome back. Before we go, we have one last thing.
There are people out there that want to help and support you. Just keep looking and keep asking questions. You're just as capable as anyone else to do it.
I think a lot of times women in particular don't speak up for themselves. They hope that their accomplishments will be noticed because it's unseemly to be immodest.
That's it for Mission Unstoppable. Tune in next time. We'll learn why red root vegetables can't be beat. See ya. If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.